discussed about the intermolecular forces which are exist in between the gaseous molecules. So, especially the van der Waals forces. Okay, in that van der Waals forces we discussed dispersion force, Arrel-London force, dipole-dipole interaction, dipole-induced dipole interaction, and also hydrogen bond. Okay, so first one, the dispersion or a London force is exist in between non-polar molecules. Okay, so dipole-dipole interaction exists in between polar molecules, and dipole and induced dipole is exist between dipolar and non-polar molecules, and hydrogen bond is exist in between hydrogen and a highly electronegative atom. Only this much is enough. Okay. So the next one, the thermal energy effect on these forces. Okay. So what is this thermal energy? Thermal means temperature. Okay. So that temperature, how it affects on the respective van der Waals forces. Okay. For example, students, I will take an example of ice here. Here ice, here water, here gas. Okay, so it is when it heated, it converted into water. When this water is heated, it converted to plus here. Okay, when removal of heat takes place, when cooling takes place, then gas takes place. This one is water vapor. Okay, so molecular formula for ice is also this one. Water is also same. Water vapor is also same. Only the change is what? It is solid state. It is liquid state. This one is gaseous state. Understand? So yes, students, this is the best example to explain how the temperature or thermal energy affects on the physical states of the matter. If ice is there, if we supply enormous amount of energy, not enormous, ice is, water is in solid state at 0 to 4 degrees Celsius. If we supply above 4 degrees Celsius, means at room temperature, water is in liquid state. Okay, so it boils at 100 degrees Celsius. If pure water is there, that exactly boils at 100 degrees Celsius. Okay, so then when the boils means the water vapor will collect. Means this H2O is converted into what? Water vapor. Understand? Again, if we collect that water vapor and if we cool that, for example, while cooking, you may know, so water vapor is collected on that vessel tap. Okay, so they cool and again they fall back into the vessel. Understand? When you open the lid of the vessel, you can observe the downward part of that vessel is covered by water. Okay, it is not water actually, it is the water vapor. After cooling, they again form liquid state. Understand? Next, and also you know that fractional distillation process. In that fractional distillation, 2 boiling point liquids will be there here. So assume here liquids are there, here it is supplied. Okay, here condenser is there. Are this water vapors or any vapors? This one is condenser, means cooler. Condense means cool. Understand? You know in the engine you will always used to say the condenser and the coolant. Understand? In nuclear power reactor you are telling like there is a coolant, there acts as a moderator like that. Understand? Condenser means which used to cool the water vapor. So listen, not only water vapor, any liquid is there, if it boils the gas will evolve. That gas is moved to this tube and here condenser is fixed. The condenser fixed means this is consists of a water or ice or anything else. Understand? So it cools this water vapor. That means what? It again converted into liquid state and here the pure liquid will get aligned. Understand? From liquid to gas, gas to liquid. Here we are heating, so liquid converted into gas. Here we are cooling, so gas converted into again liquid. That means by giving a temperature, solid changes to liquid, liquid changes to gas. By cooling, the gas changes to liquid, liquid changes to solid. Understand? So this is a thermal energy effect on the intermolecular forces. So students, intermolecular forces I am telling means this is thermal energy is there. Solid means they are arranged in this manner. Okay, liquids means in this manner. Gaseous means like this. Okay, so if solid is there, after giving the temperature, after heating, heat, it changes to what? Liquid. Here from year to year, intermolecular force decreases. Understand? Here intermolecular force between the two atoms is very high because they are nearer to each other, adjacent to each other. Here they are nearer to each other, not adjacent, they are very close to each other. Okay, so then compared to solid, here the force of attraction is less. So upon heating, the force of attraction decreases. Here also, from liquid to gas you compare this, here heat. So upon heat, the intermolecular force decreases. You know, the force between the liquid atoms and the gaseous atoms, if we compare, here the force is less, here the force is more. Here the distance is more, here the distance is less. Force and distance are inversely proportional. Understand? If you cool, then force increases because it becomes gas to liquid. Understand? This is how the thermal energy affect on the forces. If the thermal energy increases, intermolecular force decreases. Understand? If the thermal energy decreases, intermolecular force increases. So thermal energy is inversely proportional to distance. Okay? So the next one is different laws that explains about the behavior of the gases in the environment. Okay? Before that, students, in the entire periodic table, how many gases are there? Means from nitrogen, first I write how many gases are there. Okay, hydrogen is there in group 1. Correct? Next, nitrogen, oxygen, chlorine, bromine, iodine. Bromine is a liquid, liquid non-metal it is. So chlorine, and all the noble gases, helium, neon, argon, krypton, xenon. Only these are gases present in the periodic table. Hydrogen, nitrogen, oxygen, chlorine, helium, and the noble gas. Understand? And how these will interact with the molecules, how the forces varies in the environment based on the temperature, based on the pressure. So that is explained by the different laws. Okay, I'll discuss one by one last student. So 5 laws explains the behavior of these gases. Among them, the first one is Boyle's law. Okay, second, Charles law. Third, Gay-Lussac's law. Fourth, Avogadro's law. And the last one, ideal gas equation. Okay, so these are the 5 laws which tells about the behavior of the gases. Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, and the ideal gas equation. Understand? So we will discuss one by one. So first I will go with Boyle's law. Okay. So what is this Boyle's law? Before that, let me ask if listen. Here gases are there, gaseous molecules are there. Here piston is there. Here it is piston. Okay, so these are not gaseous molecules, they are far away from each other. So here the distance is here. Compare another. Okay, so at this initially pressure P1, so this is the volume of the gas. When we apply pressure on the piston, then the pressure piston moves inward. Understand? Let me explain you it. So listen. ಇಲ್ಲಿ ನಾವು ಪಿಸ್ಟನ್ ಮೇಲೆ ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇದು ಒಳಗಡೆ ತಳ್ಳುತ್ತೆ, ಈ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ಹತ್ರ ತಳ್ಳುತ್ತೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಪಿಸ್ಟನ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಇಫ್ ಇಟ್ ಮೂವ್ಸ್ ಫ್ರಮ್ ಇಯರ್ ಟು ಇಯರ್, ಸೊ ಲಿಸನ್, ಫ್ರಮ್ ಇಯರ್ ಟು ಇಯರ್, ದಿಸ್ ಮಚ್ ಇಷ್ಟು ಅದು ಮೂವ್ ಆಗಿದೆ ಪಿಸ್ಟನ್ ಅಪಾನ್ ಅಪ್ಲೈ ಪ್ರೆಷರ್. Piston is here. When we apply pressure, it shifts here. Then what happens? These compresses. That means they are arranged like this. Compared to here and here, volume becomes less. From here to here, or from here volume is this much, here volume is only this much. So if the pressure is more, then volume is less. That is explained by this Boyle's law. Understand? I'll write the explanation statement that is very important. At constant temperature, at constant temperature, understand? The pressure of fixed amount of a gas. Pressure of fixed amount of a gas is inversely proportional to volume. So this is the statement of Boyle's law. What it is? At constant temperature, the pressure of a fixed amount of a gas is inversely proportional to volume. Okay? So remember why we are considering the constant temperature means because here it is assumed 25 degrees Celsius is there. Okay? Here 25 degrees Celsius is there. Then what happens? It has so here 9 gaseous molecules are. Understand? Or you assume instead of this, here liquid is there. This liquid at 25 degrees Celsius forms this much of gaseous molecules. Understand? So now the pressure increases means this the volume becomes this much. Understand? Next students, if the same liquid, if the temperature is 100 degrees Celsius, then the formation of gaseous molecule is more. Understand? Here at 25 degrees Celsius, it forms only this much of gaseous molecule. At 100 degrees Celsius means It easily converts from liquid to gaseous state. So many molecules of liquid is converted to what? Gases. So then what happens? Here the gaseous concentration increases. Understand? If the gaseous molecule increases, if we apply pressure also, then we cannot compress them. Then what happens? Instead of moving piston this side, it will move above. Then from here to here, it becomes piston moves here. Understand? That's why we are considering a constant temperature. Because at the constant temperature, number of moles or number of atoms of gaseous atoms in both the cases remains same. Understand? If the temperature varies, this will happen. So Boyle's law is a law which tells about the constant temperature and which the pressure of fixed amount of gas is inversely proportional to volume. Fixed amount means if it is 1 liter, this must be a 1 liter. If it is 1 mole, this must be a 1 mole. Fixed amount only. If the mole is more means, then number of gaseous particles is also more. So amount of a substance should be present same. Temperature must be same. Okay. So if we draw a graph, so before drawing the graph, I'll get the mathematical expression for this. So mathematical expression. Mathematical expression. So students listen. Here what it says? At constant temperature. At constant T. The pressure of a fixed amount of a gas P is inversely proportional, means 1 divided by to what? Volume. So this is a mathematical expression of a Boyle's law. To remove proportionality, you may take P is equal to K 1 divided by V. This K is a proportionality constant. To remove this proportionality, understand? P is equal to K into V. These two are the mathematical expressions of the Boyle's law. They'll ask the question, state Boyle's law and its mathematical expression. Okay? So if two or more temperature is there, two or more different volume is there. Okay? Consider and take at 0 degrees Celsius, P is equal to P1, V is equal to V1. So under T degrees Celsius, P is equal to P2, V is equal to V2. Correct? And both are equal to what? K. Because listen, if you cross multiply these, you get PV is equal to K. Understand? So first initially at 0 degrees Celsius, P1, V1 is equal to K. Because as I told you, that is already a constant. Next, at T degrees Celsius, P2, V2 is equal to K. This is equation 1, this is equation 2. If right hand side same means we have to equate left hand side. Correct? So the here P1, V1 is equal to P2, V2. This is the Boyle's law for the two or more variables. Sorry, instead of P2, V2, if P3, V3 is also there, P1, V1 is equal to P2, V2 is equal to P3, V3. Understand? So this is a Boyle's law expression. So first remember students, here always they'll ask in the problem based on this only. They give at 298 Kelvin. If the pressure of at 1 bar pressure, the volume of this gas is 1 mole. And at 2 bar pressure, what happens to the volume? At 298 Kelvin, the given means it is a constant temperature. The pressure means, as I told you, at 298 Kelvin and the volume of gas is 1 mole. 1 bar pressure. Okay, calculate volume of gas at 2 bar pressure. Assume. Okay, here they given at 298 Kelvin means this is a constant temperature. This follows what? Boyle's law. Here V1 is equal to they given 1 mole. P1 is equal to 1 bar. P2 is equal to they given 2 bar. V2 we have to calculate. So from this P1, V1, P2, V2 we have to apply. P1 means 1, P2 means 1, P2 means 2, V2 means question mark. We don't know. So V2 is equal to 1 by 2, that is 0.5. This is the way to do the problem. Okay, so from whether the constant temperature is there, constant pressure is there, or constant volume is there, based on that we can say the which law it is. If constant temperature, that is Boyle's law. So we have to follow this equation. If constant pressure is there, that is Charles law. We have to follow another equation. Okay, so while solving the problem, I will explain. So this is all about the Boyle's law. So if we draw the graph, understand? So here what we know, if the pressure increases, volume decreases. So we consider graph now. So let's show graph is there. Here this is volume V. This one is pressure. Okay. If pressure is more, then volume is less. So here 0, 100, 200, 300, 400, 500. Okay. This is 1 mole, 2 mole, 3 mole, 4 mole, 5 mole, 6 mole. Assume. Okay. So this is volume increases. When the pressure is more, volume is less. Means volume is here means that means what? Pressure is here. When the pressure decreases, then the volume increases. Like this. When the pressure decreases, then at that time volume is more. When the pressure is less, then volume is more. When the pressure is more, then volume is less. So the graph follows like this. It increases gradually. This is a T1, this is a T2, this is a T3, and this is a T4 at different temperatures. As I told you, the temperature remains constant. Assume this is a 300 Kelvin, this is a 400, this is 500, this is 600. So in all the temperature, always the graph means if the pressure increases, volume is less. If the pressure decreases, volume is more. So this is the graph which is pressure versus volume. So instead of volume, by comparing with this, if we take pressure versus 1 by V. Pressure versus 1 by V. So students, this is the PV is equal to what? K. Correct? Always starts from 0 and increases in this number. Understand? This is a temperature T1, T2, T3. If it is 1 by V. This is the graph variations. So here if you want to see, here T3 is greater than T2, T3 is less than T2, less than T. Understand? So this is the graph which tells about pressure versus 1 by V, inversely proportional to volume. These are the two graphs. Understand? So this is all about Boyle's law. Understand, students? So listen. And once again I explain, Boyle's law means at constant temperature the pressure of a fixed amount of a gas is inversely proportional to volume. So this expression is written like this: the pressure is inversely proportional to volume. To remove this proportionality, we are taking K. This K is a proportionality constant. So here it becomes PV is equal to K. Understand? Means the product of pressure and volume of a given amount of a gas or a fixed amount of a gas is always constant. Understand? Product means multiplication, you know that. The product of pressure and volume of a fixed amount of a gas always is constant. So here this is the variable of the or extended form of the Boyle's law. If two or more, we have to consider the volume or pressure at two different temperatures. At 0 degrees Celsius, it is P1 V1. At T degrees Celsius, it is P2 V2. By comparing these two, students, we will get the expression P1 V1 is equal to P2 V2. From that, we can get the answers. So this is the graph which tells about the variation of pressure and volume. Understand? So the next one is, and remember, so here these curves tells about the different temperatures. As I told you, T1, T2, T3. So these are called as isotherms. These are called as isotherms. The curve in the Boyle's law graph is called as isotherms. Therms represents what? Temperature remains constant. Iso means same. Therm means temperature. So these graphs tells about the same temperature. So this one is graph at the temperature 200 degrees Celsius. This graph is at 300. This graph is at 400. Like that. They are isotherms at same temperature. The graphs are at same temperature. Understand? Isotherm. Therm means temperature. You know that. Next, the second one is Boyle's law. Second one is that is Charles' law. Okay? So listen, first I write the statement. At constant pressure, okay, the volume of a fixed amount of a gas is directly proportional to absolute temperature. Okay, so at constant pressure, the volume of a fixed amount of a gas is directly proportional to absolute temperature. Okay, so what is the difference between temperature and absolute temperature means? Okay, so listen students, you know, for example, any degree Celsius is there. Understand? How do you convert degree Celsius to Kelvin means? You are going to add 273.15 to the respective degree Celsius. For example, 30 degrees Celsius. Okay, you have done 30 plus 273.15, you will get 303.5 or 15 Kelvin. Understand? So the degree Celsius by addition of 273.15 it is converted into Kelvin. This 273.15 is an absolute temperature. Means that 0 degree Celsius. 0 degree Celsius or 273.15 is called as absolute temperature or Kelvin temperature or Kelvin scale. Understand? So always what it is, the volume of a fixed amount of a gas is directly proportional to its absolute temperature, either at 0 degree Celsius or at a 273.15 Kelvin or at a respective temperatures whatever consider. Understand? So this is the statement of a Charleston. What it states? A fixed mass of a gas is directly proportional to its absolute temperature. Understand? So students here, if you want to this mathematical expression, okay, here it tells about what? At constant pressure. Okay, at constant pressure. Here, the volume of a fixed amount of a gas V is directly proportional to the absolute temperature, means T. Understand? V is directly proportional to T. Next, to remove this proportionality, we have to take V is equal to K into T. K is the proportionality constant of the Charles law. Next, this will become V by T is equal to K. Understand? You may write this and this. All are represents what? Charles law. So students, if you want this expression for different variables, like at pressure P1, it is constant as I told you. Okay, then what happens? This V is equal to V1, T is equal to T1. Next at pressure P2, V is equal to V2, T is equal to T1. So if we compare the students, this equation, V1 by T1 is equal to K and V2 by T2 is equal to K. If both are equals to constant, then this equation becomes V1 by T1 is equal to V2 by T2. This is the expression of a Charles law which tells about two different variables. Understand? This one is Charles law. So listen, all this Boyle's law, very mathematical expression. Charles law and its mathematical expression. Gay-Lussac's law and its expression. For Gay-Lussac's law, nothing expression. Sorry, no, nothing is there. So Avogadro's law and its statement and its value. Okay, not expression. Ideal gas equation is the derivation for 3 marks. So all these laws are very important towards exam orientation. Understand, students? So this one. Listen. This tells about what? The volume of a fixed amount of a gas is directly proportional to absolute pressure. I'll take this. So here, this is the container. In this is the volume we are considering. Okay. So assume here piston is there. Again, same pressure is there. Understand? We are not changing any pressure. But both the cases, the pressure is equal because we want that constant pressure. So students, as I told you before, it is a liquid. Correct? Here it is 25 degrees Celsius. Here it is 100 degrees Celsius. What I explained before. So at 25 degrees Celsius, if this, assume this is only water Water at 25 degrees Celsius, it never boils. Okay, only. Or you assume 30 degrees Celsius. Means at the 30 degrees Celsius, they form only less amount of water vapor. Means 1 or 2 water vapors like this. Whereas because it is in a liquid state at 25 degrees Celsius or 27 degrees Celsius, we are just increasing them by very slight manner. So the formation of vapor pressure is less, the volume of the gases is less. Here what I am telling? The volume of a fixed amount of the gas, that is less. If we increase it into 100 degrees Celsius, water completely boils. So all these liquid converted into what? Gases. Here what happens here? At the same pressure only by increasing the temperature, here the volume of the gas increases, here the volume of the gas is less. That means if the temperature is less, volume of the gas is also less. If the temperature is more, volume of the gas is also more. Understand? That is what Charles' law. It tells about the volume of the gas is directly proportional to the absolute temperature. Remember, absolute temperature means it is either 0 degrees Celsius or 273.15 Kelvin. Or you may simply write exactly it is 273.15. If you write 273, you lose marks. Either you have to write 0 degrees Celsius or 273.15 Kelvin, which is very important for water. You take note of this absolute temperature is equal to 0 degrees Celsius or 273.15 Kelvin. Very important for 1 mark. Understand? So the next one is graph which tells about the variation in this Charles law. So students, here we are taking temperature, here volume. So here students, it is minus 300, minus 200, minus 100, 0, 100, 200, 300. Okay? So listen. Okay. Students, here volume is there if temperature is there. Temperature is less, volume is less. If temperature is more, volume is more. Assume here it starts from 0 degrees Celsius means 273.15. Take here. Here instead of the value 0 degree, 100 degree, 200, 300 degrees Celsius, 400 degrees Celsius, 500 degrees Celsius. Okay? So initially it starts from 0 degree. As the temperature increases, this is 1 more, 2 more, 3 more, 4 more, 5. Or you may say 100 cm cube, 200 cm cube, 300, 400, 500. Volume in cm cube. Understand? So initially when the temperature is 0, this volume is also has some value. So as the temperature increases, then the curve also increases at different pressure values. So assume this one is P1, this one is P2, this one is P3. Understand, students? And compare, if pressure is more, volume is less, correct? So volume is here. That means P3 is greater than P2, greater than P1. P3 is greater than P1 greater than, sorry, P2 greater than P1. Why? Because here we are comparing, listen, at P1 degree Celsius, sorry, P1 pressure or P3 pressure, this is at 300 cl. At P2, this is at 400 cl. At P1, it is at 500 cl. You know, according to Boyle's law, if pressure is more, volume is less. Your volume less means this is the greater pressure compared to this, compared to this. That's why P3 is greater than P2 greater than P1. Understand? So students, these curves are called as isobars. As we know, the pressure is expressed in bars. Atmospheric, 1 atmospheric you may say, 1 bar pressure you may say. So that's why these curves are called as isobars. Iso means same, bar means pressure. The curves of the same pressure, that tells about isobars. Understand? So this is all about the Charles law. You have to remember this one explanation, the statement of the law and mathematical expression. This is the variable with respect to two or more, the equation with respect to two or more variables. Understand? And this is the graph. In that graph, these are called isobars. And this one, absolute temperature means 0 degrees Celsius or 273.15 Kelvin. Okay.